We're going to look at the series from n equals 1 to infinity of the cube root of n cubed plus 3n squared plus 2n plus 86 divided by the square root of 2n squared plus 9n plus, say, 285. We want to know if this series converges or diverges, and we'll be using the test for divergence. You should always at least look at the test for divergence whenever you encounter a series you don't recognize. So if you recognize a series that is, say, not geometric, try test for divergence first, because it could save you a lot of time. Here's what test for divergence says. It says if we have a series, it doesn't matter where it starts, so say it starts at 1 to infinity of an, and if the limit as n goes to infinity of the sequence that gives us the series, that is the sequence an, is not 0. Now that could mean the limit is 5 or 1/4, or it doesn't exist at all. As long as it's not 0, then the series from 1 to infinity that we were looking at, an, diverges. Now this is what test for divergence says. What it doesn't say, and is often assumed by some students, is the following. So I want to make this clear that you don't make this mistake. It does not say if limit n goes to infinity an does equal to 0, the series converges. That is not true. If the limit n goes to infinity of an is 0, the series could converge, may converge, or it may diverge. So we just means we have to try something else. That's why we develop all kinds of tests other than tests for divergence. So if the test for divergence is inconclusive if the limit n goes to infinity of an is equal to 0. So let's return to the series, that is the series from 1 to infinity. In the numerator we have a cube root of n cubed plus 3n squared plus 2n plus 86, and in the denominator we have the square root of 2n squared plus 9n plus 285. We're going to take the limit of that sequence that gives us the series, that is the limit n goes to infinity, cube root in the numerator, so it's cube root of n cubed plus 3n squared plus 2n plus 86 divided by the square root of 2n squared plus 9n plus 285. Now we want to evaluate this limit. Probably the easiest, simplest way to do it is to do some factoring. In the numerator we're going to factor the highest power of n, which is n cubed, and that leaves 1 where n cubed used to be, plus 3n squared over n cubed is 3 over n, 2n over n cubed is 2 over n squared, and 86 over n cubed is 86 over n cubed. And we'll do the same thing in the denominator. We're going to factor the highest power of n inside the radical in the denominator, that is n squared, and that leaves a 2 plus 9 over n plus 285 over n squared. And so now we'll do one more step. We'll take the cube root of n cubed, which is n, so this is the limit as n goes to infinity. Cube root of n cubed is n, times the cube root of what's left, which is 1 plus 3 over n plus 2 over n squared plus 86 divided by n cubed. Same thing in the denominator. Square root of n squared is n, and then square root of 2 plus 9 over n plus 285 divided by n squared. Now we can cancel the n's, and look what happens when we let n go to infinity. Everything with a constant in the numerator and the power of n in the denominator goes to 0. So 3 over n, 2 over n squared, 86 over n cubed, 9 over n, 285 over n squared. They all go to 0. and that leaves cube root of 1 in the numerator, which is 1, and square root of 2 in the denominator. So this limit is 1 divided by square root of 2, which is clearly not equal to 0. We wanted to know if the limit is 0, in which case test for divergence would be inconclusive, or if it's not 0. If it isn't 0, we can now safely conclude that the series from 1 to infinity of cube root n cubed plus 3n squared plus 2n plus 86 divided by the square root of 2n squared plus 9n plus 285 diverges by the test for divergence. For more videos, visit www.mathprepvideos.com.